Okay, hi, welcome. We're going to talk today about a deep dive into TUF, what's new about TUF. I'm Marina Moore. I'm a PhD student at NYU, and I'll be presenting here with Trishank.
Hi, thanks, Marina. So I used to work at NYU on TUF with Marina too, and with our advisor Justin Campos, and where particularly I did my research on a fork of TUF called Update, which is securing software updates for ground vehicles. So that was a lot of fun. And now I'm a staff security engineer at Datadog. Please go ahead, Marina.
Okay, so let's get started. I think we'll get started with a bit of background about TUF, and then go into kind of some of the current evolution of the project. So there you go. So first of all, I'm going to go a bit into the problem that TUF is solving. So software updates are a really key feature for security of applications. Experts agree that this is like the #1 thing you can do to keep yourself secure on the internet, because every time a vulnerability is found in a piece of software, in order to get a patch out to users, they have to update their software to get the new version of the software. However, the actual software update process itself has a few security problems that also need to be considered as well. And if these are not considered, you get what's called a repository compromise. So if the repository that's hosting your software updates is compromised, the images on that repository can be replaced with malicious images or malware or something like that, which can lead to vulnerabilities in all the systems that are using your repository. This happens actually in practice fairly often. Pretty recently, Docker Hub had a password DB compromise in 2019 that luckily they were actually using TUF through Docker Content Trust, and because of that, the impact of this was mitigated. But this vector has been used to spread malware through, like the Flame malware, if you've heard of that. That was spread through a repository compromise, and there are other large-scale ones. And so the goal of TUF is to provide compromise resilience. It's basically impossible to prevent every single repository compromise, to close every single security hole your application could ever have. So instead, what we try to do is have compromise resilience, so that if and when your repository is compromised, you're able to detect that compromise and recover from it in a secure way to minimize the impact. So to do so, we're going to present the update framework, or TUF. So a bit of background about the terminology we'll be using in this talk. So first of all, we talk about this thing called the repository and the repository compromise. And what we mean by repository is the entity that contains your images and metadata. And in the context of OCI, this is actually like the registry, the OCI registry, rather than a container repository in that context. But on this repository, what you have is an image, which is kind of the smallest unit of an update. This is the thing that you want clients to install and run on their program. And you also have some metadata, which is kind of information about these images or about other metadata files. And this metadata can contain things like cryptographic hashes, file sizes, version numbers, signatures, anything like that. Okay, so we're going to present the update framework. And the goal of this framework is to provide authenticity and integrity even in the event of a repository compromise. And to do so, it's based on it uses a variety of design principles that are baked in from the ground up in order to achieve these goals. And I'll focus on a few of these in the next few slides. For more information about TUF and the problem that it's solving, this framework was first introduced in CCS in a paper in 2010, so you can find a lot more detail there. So yeah, the first principle I'll talk about is the separation of duties. And the idea here is that you don't want any single entity to be in charge of the security for your entire system, because then in the event of a compromise of that one entity means all of your security is now gone. So TUF does this through the use of 4 different key roles. And each of these roles is responsible for signing different pieces of metadata on the repository. So I'll go through each of those. First, we have the targets role, which is, this contains information about the images themselves. So this is when you think about like cryptographic hashes and file sizes, and other information about the actual images that you want people to install. And one of the cool features of TUF is that the targets role can actually be split into multiple different roles. Each one can delegate trust to other roles so that there isn't even a single entity in charge of signing every single image on the repository. That can also be further separated. And we have the snapshot role, which is in charge of kind of consistency of images on the repository to make sure that the view of the repository that a user is getting includes the actual state of the repository at a given time. Then we have the timestamp role, which contains information about the timeliness of updates. So it tells you that these updates are actually current. They weren't from 3 years ago, they were from today, and this is the current state. And this also can be used to tell clients when there's a new update to be installed. Because if this changes, and if it's signing a new set of images, that means that there's something new and that people should do an update. And finally, and kind of most importantly, we have the root role, which is the root of trust for the entire system. It tells the client which keys to trust for all these other roles, and it's kind of the root of the security for the system. And because of the way this is all separated into these different pieces, the root role can be protected even more strongly than the other roles, and it can be updated less frequently, which means that you can maintain this higher level of security. Yeah, those are all the different pieces that come together to get the separation of duties. The next principle that we have is threshold signatures. So within each of these roles on the repository, you don't need just the single signature on it. So for example, if you have a targets role, you could have 4 different entities that are allowed to sign for the targets role, and you can require that at least 3 of them have valid signatures on the targets file before it's trusted by the client. So that if any single key is compromised, that can't lead to a compromise of any role because you need 3 people to agree on a piece of metadata. Next, we have explicit and implicit revocation of keys. So this is also important for in the case of a key compromise, there's a way to get rid of these bad keys and tell people what new key to trust instead. So there's implicit revocation by having expiration times on all keys. So that after some period of time, it can be like weeks, months, years, a key will expire, and then you have a new key has to be signed by the system and the trust has to be established. And there's also explicit revocation, so that if a compromise happens, or if somebody loses a key, or if anything else goes wrong, there are ways to explicitly delegate to a new key, and this is built in from the ground up. Finally, we have minimizing risk through the use of offline keys. So because of the separation of duties, things like the root role can be updated less often, which means that you're able to sign them with offline keys. And these keys can never be stored in a way such that they can never be accessed on the internet. So you can use them offline and then put them in a device and put that in a locked safe somewhere, so it's totally inaccessible. And then you can use that metadata to generate your trust and put it online. But then this actual key is stored offline. And this means that if anyone wants to compromise this offline key, they can't actually do it online. They'd have to go find your locked safe and do some kind of Ocean's 11 stuff to get your system compromised. And finally, TUF supports the diversity of cryptographic algorithms, which means that you can use, first of all, any algorithm that you would like in your system, and also multiple different algorithms for things like signing and hashing, so that your system is secure as long as at least one of these algorithms is secure, which is very likely to be true. And this even allows you to use things like post-quantum crypto or any other new crypto techniques as they come forward, and those will still be able to work within this system. Okay, now I'll pass it on to Trishank to talk about the current state of the project.
Great, thanks, Marina. So yes, let's talk about, so now that Marina has presented about how TUF roughly works, especially in the context of container image registries or even any OCR artifact you like, let's talk about where we are now and where we're going next. Next slide, please. Thank you. So the first good news is that we graduated on the CNCF project. We were accepted into it in 2017, and I'm very, very pleased to say that we're the 9th project to graduate after so many other, luminary projects. We're also the first one to get the best practices CII badge for silver badge, and we're working hard to get the gold badge, hopefully coming next. A huge thanks to all of our contributors. We could not have done this without you. So thank you. And so let's talk next about some deployments, old and new. I think all of you are probably most familiar with perhaps the most popular incarnation of TUF is Docker Content Trust, which uses a specific tool called Notary, which is used to sign container images most commonly. And you might have seen some registries supported already, such as Azure, Quay, IBM, Docker Hub, of course, and also Harbor, which is another CNCF project that we'll talk about shortly. Next slide, please. So the first interesting development over the past year is something called Amazon Bottle Rocket, which is a special purpose container OS that Amazon developed. It was launched just a few months ago on March 10th, and it's basically designed for security, consistency, and operability. Now, the interesting thing is that it's one of the few operating systems that fundamentally uses stuff out of the box to secure its software updates, which is great, which we think should be the future of all operating systems going forward. They particularly wrote a Rust library for TUF called TUF, which is a very clever pun. And you can visit the link below to get more information. The next interesting development is something called cloud native application bundles, which we believe will interest a lot of you. In particular, it's a package format to facilitate the bundling, installing, and managing of container native apps, right? And all the services that support them too. So for example, you could bundle your application as a bunch of related images, such as your web app and your database images and so on, and talk about how to install them on Azure, or Google, or Amazon. And it's the same application that's installed everywhere, despite superficial cloud differences underneath. And so the interesting thing is that it uses stuff in a sister project of ours called Intoto to secure the distribution of bundles end to end. The CNAP security spec, I'm very happy to say, was merged just last month. Many thanks to Radu Mate and Ralph Squillaci at Microsoft for helping us to push this along. So please visit cnap.io to get more information on that. The next interesting development is that, 2 years ago, we presented at KubeCon North America about how Datadog, so first of all, Datadog is a SaaS platform that some of you may know, that analyzes your infrastructure metrics and your application performance and logs for your DevOps purposes. And in particular, we have something called the agent, which you install on your host, and integrations are like plugins for the agent that let it collect even more metrics and logs and events and so on. Now, the key thing that you need to know is that we use stuff in our sister project in Toto. We believe this is the first in the industry as far as we can tell. There's no trusted hardware here well, except for something called YubiKeys that a developer use. But basically, we can build our agent integrations, and it is in fact happening today when you're using the agent to install or upgrade. We build it and distribute it in such a way that any attack, anywhere between our developers and end users, will be detected and prevented, which is the sort of compromised resilience that Marina was talking about. And some new features we were able to do this year was we basically, using TUF, very easily associate different software supply chains with different packages without breaking backwards compatibility for our end users, and also revoke developer keys, again, without breaking packages for users who want those old packages. So please visit the link below for more information on that. Next is Google Fuchsia, which is an open source capability operating system from Google. So the interesting thing is that just like Amazon Bottle Rocket, its software update system natively uses TUF, which is very good, which is what we believe that future operating systems should do. So your operating system itself is compromise resilient in terms of updates. They originally forked the Go TUF, and now they contribute and use something called Rust TUF. So if you're interested, please visit the link below for more information. Harbor, which is a sibling CNCF project of ours, their mission is to be the trusted cloud native registry for Kubernetes. And the interesting thing is that besides other security features such as scanning your images automatically for CVEs, is that they also support content signing with Docker Content Trust, a variant of TUF, out of the box. And the good news is they graduated from the CNCF just last month. So congratulations, this is fantastic news. Notary. So Notary V1, as we call it colloquially, is the version of the tool that you use right now to do Docker Content Trust. The project itself is now looking to improve the usability and security for future use cases that Notary V1 does not support out of the box. And we have been working with them to leverage some new features and stuff that Marina will be talking about shortly, actually. The long story short is please join us on the Notary V2 channel on CNCF Slack for more information. We would love for you to join us, particularly people from the Harbor community, which we think would be interested in this development. So please visit us there. Last but not least, we're very, very excited to inform that PEP 458, which we co-wrote, Marina and myself wrote, has been accepted into the Python package index, which many container images use. What this basically means is that we're building the first stepping stone, right? Which is to secure the distribution of 246,000 Python packages projects. It's the first open source programming language we know that does this, that basically uses stuff to secure. So even if you hack PyPI, the damage that attackers can do is limited. This is fantastic. This is basically another first. Thanks to Facebook Research for funding and too many names, unfortunately, that I can list right now in PyPI and VMware that are helping us to implement this as we speak, actually. We hope they'll be ready in a few months. So please visit the PEP for more information. Thank you, and please take it away from here, Marina.
Okay, so yeah, I'm going to talk about a few new features in TUF that were kind of inspired by some of those projects that Trishank just went through. So a lot of these new features are presented through these things called TAPs, or TUF Augmentation Proposals. So basically what this is just a design document for TUF that includes a technical specification and a detailed rationale. And so the idea is that you can document new features, have some new documentation, and also just have some in-depth discussion and consensus building before something gets implemented in the specification and all of our implementations. So the first one of these I'll talk about is TAP 11, which is using proofs for interoperability. So TUF doesn't mandate specific implementation details such as wireline formats or, like we talked about before, the cryptographic algorithms. We allow people to use whichever ones work for their system. However, because there are so many different implementations of TUF, sometimes these different implementations want to be able to interoperate. And so to allow for that, we created these things called proofs, or protocol operation usage and format documents, which describe all the elements, in addition to those elements described in the specification, that are needed for interoperability and full use of the system. And next we have TAP 13, which allows for user selection of top-level targets metadata. So if you have a large public repository that hosts a lot of different images, specific clients might want to use only a subset of those images on this public repository. So in this case, what they can do is they can define their own top-level targets metadata that replaces the one on the repository, and use this to decide which images they actually trust. And so this can be used like for an organization to decide, we trust these developers and the images they make, but not necessarily every single image on this repository. And then next we have TAP 14, which allows for succinct hashed bin delegations. So TUF allows for this technique called called hashed bin delegations, just without the succinct, already. And so what this does is if you have a single role who wants to delegate to a lot of other roles and to a lot of other images, what they can do is instead of delegating directly to all these different images, which can create kind of a huge metadata file to list them all, they can delegate to these intermediate bins, which use the hash of the image name to to delegate and make it much more efficient. And when using this with PEP 458 and the PyPI implementation, what we realized is that this could be even more efficient in the way it describes these different bins. And so this tap basically adds that extra optimization to describe these bins in a very succinct way to kind of save on metadata overhead and make it much easier to use. And next we have an as yet unnumbered tap for snapshot Merkle trees. And so the idea here is also for very large repositories, which is kind of a theme in these new features. But when you have a very large repository, the snapshot file, which lists the version number of all of the different images, can get really large if you have a lot of different images that you're listing. And so what this proposal does is it kind of separates that snapshot file out into a different file for each image, and then it connects these using a Merkle tree so that you still get most of the security properties of the snapshot role, with much less metadata overhead. And there's more details of this available, this and all the other tabs available in the documentation and on our website. So next, I'll talk a bit about how you can get involved in this project and all the different efforts that are going on around TUF. So here are kind of the key ongoing discussions that are happening right now. There's the maintenance of the TUF specification and the reference implementation. So what the TUF project is primarily is a specification that describes how anyone can do secure software updates. And we also maintain a reference implementation written in Python that kind of demonstrates how this can be done. The reference implementation is used in practice as well, but we also support all of the other projects that Trishank was talking about. They all have their own implementation of, or most of them have their own implementation of TUF that they use. And so both of these require maintenance and ongoing support. So if anyone is interested in getting involved there, we always appreciate help. Next, we have the Notary v2 effort to improve, improvements to Notary. I think this is really relevant to the cloud native space. So if anyone is interested in getting involved here, there's a lot of discussion happening and it's still in the early stage. So it's a good time to get involved and have your ideas be heard. And so there's a lot of discussion happening on the Notary v2 channel on the CNCF Slack. So feel free to join there and contribute. And finally, on this list, there are many other options, but for this list, we have the TUF integration in PIP. And so these are there are two kind of separate things that have to do with the use of TUF in PyPI. So with PEP 458, what happened was we got TUF into PyPI itself, but PyPI is just kind of like the server side of the update process. It's just the repository. In order for this to actually be useful and to provide increased security, we also need TUF integration in PIP and other downloaders that use PyPI, so they actually do those verification steps that are allowed because of the metadata provided. And also there's this other PEP that we wrote called PEP 480, which includes what we call the maximum security model. So PEP 458 is kind of a minimal implementation of TUF to kind of get started and get some initial security features. And then PEP 480 provides even more in-depth security features, including end-to-end developer signing and some other really cool things. And so that's another place where you can get started, and those are in the early stages, and so good things to get going on. And finally, we would like to thank a lot of different people who have made all of these different things possible. There are, of course, more people than we could list on this slide, but this is a nice sampling of all the people who have helped make TUF possible and all of the TUF projects successful. So thank you to everyone here. And thank you all for coming, and we will be available live for questions at the talk.
Yes, thank you.
Okay, thanks. Thanks for both speakers for the great talk. Now let's start the Q&A session. You can take a look at the Q&A tab in Zoom and answer any questions. Thanks.
What is the participation level status of end user as compared with software vendors in TUF? I'm sorry, I don't fully. don't fully understand the question. Marina, do you have a guess?
Well, I guess so TUF is mostly transparent to the clients and to the end users. Mostly we work with people developing update systems to get them to implement TUF and get it, just kind of put it in the pipeline. And then once it's there, it kind of automatically provides this protection. And clients are really only aware of it if there's a problem and the error messages come up. So I think otherwise it's pretty much transparent. And so because of that, we tend to get much more participation from kind of developers and people making the software. Does that answer the question? Feel free to ask again if it doesn't.
Oh yeah, I suspect you're right. Yes, I think that's right. Yeah. So end users don't normally notice anything unless a security attack is detected.
Yeah.
Yeah, please feel free to write down your questions in the question tab, and yeah. Okay, here we go. We have another question.
What's the mechanism, or is there any roadmap for TUF to deal with cloud-native zero-day security breaches? That's a good question. Marina, would you like to start, please?
Sure. So I guess it depends a little bit on which part of the ecosystem that this zero day would affect. I think one thing that TUF is very helpful with is providing once there's a patch for a zero day, you can securely provide this patch to all your users so that people don't stay vulnerable for very long. And so I think that's a key thing that this offers. I think the system's also built with a lot of safeguards in place so that if any one piece of the system goes wrong, you still have other pieces of the system to fall back on and recover from any kind of compromise.
Yes, exactly. I think Marina did a very nice job there. In particular, you want to use something like TUF to update, to fix your zero day, right? You need an update just to fix security exploits in the first problem. But what you want to do is make sure you use an update, time-tested update mechanism like TUF to make sure your update mechanism itself doesn't have CVEs. Right? You don't want that. It's a bad place to be. Yeah, next question from Brian Wu. Is there any visualization tools for user to know the current status of Kubernetes cluster security? I don't know. I'm not aware of the top of my head although you might be able to use Datadog we're slowly rolling out new security monitoring features that you might be interested in, that you might be able to visualize things like which software updates have been applied or not. So I don't know if that fully answers your question, but that's one possible method.
Okay, thanks Trishank and Marina again for the great talk today, and thank you.
Great, thank you. Thank you all. Have a good one.
Yeah, have a good one. Yeah. OK，感谢嘉宾的精彩演讲。那再次感谢所有讲师带来的精彩分享，也感谢屏幕前开源的小伙伴们的积极互动。今天我们第二天的在线云原生技术大会活动到此结束。我们在大会官网会开启多场在线活动，包括华为、阿里、腾讯等赞助商均有大礼相送。不仅有开源技术专家在线实时教学，还可领取诸多好礼。线上扫码参与活动即可领取礼品，欢迎大家前去参与活动。感谢大家一天的陪伴，明天精彩继续，我们明天见，谢谢大家。